Let's look at forests again in the context of this chapter. We talked about a little bit, and I don't want to sound too negative, constantly putting caveats on the trouble with forests in terms of their potential to lose all the carbon with wildfires or perturbations. But if it's a zero-sum game where economic considerations are a serious issue about how much humanity is actually going to put into drawing down carbon, then obviously one has to be aware of all the pros and cons of the approaches we take, especially if people think planting 1 trillion trees is going to be a silver bullet for climate solution, right? Okay, so here is a forest, Aspen Grove Rocky Mountain National Park. Forests have so many ecosystem services: food, fiber, medicine, biodiversity, habitats, supporting many species, and sequestering carbon. Nobody will ever question the value of forests. But when we talk about sequestering additional CO2 from the atmosphere, we do have to worry about these sorts of things. Here is the GHG net emissions in million tons CO2 equivalent per year going from 1990 to 2016. This is in the Canada's forests, and you can see the gain and loss. Canadian forests have been emitting carbon dioxide, not absorbing it, because of forests and insect kills. Okay. As global warming happens and nighttime minimum temperatures begin to increase, they are not as cold anymore. Spring is arriving earlier, winter is not as warm, as cold, or there are extreme cold events causing confusion, and so on. There are benefits in terms of agriculture and the longer growing season, but the warmer temperatures also bring insects that don't get wiped out with frost nights, frost days that should occur. So various such cascading effects of global warming, in addition to human deforestation and forest degradation, create such situations where you were just a few decades ago sequestering CO2 into the forest. You started having perturbations, but now you have just become a net source of carbon from these forests. So even if we don't worry about how much additional carbon mature forests would actually sequester, we have to worry about this part. Not to be too depressed about it, it turns out that there is actually evidence from satellite data that leaf area around the globe has increased between 2000 and 2017. Okay, leaf area includes everything, not just forest but also agriculture. China, it turns out, that actually has increased its forest cover. So its leaf area cover is actually associated with increase in forest cover, whereas India has increased some forest cover, but a lot of its leaf area increase has come from agriculture. Okay, so many questions there as well. If agriculture can still sequester carbon, or if we can make agriculture carbon neutral, or in a way that reduces emissions or increases carbon sinks, then it can still be okay. So that has to be ensured or closely monitored. There is EU and so on, and then there is some that have increased less than the global average, but you can see overall there has been some increase in leaf area. Bad news again is that if you look at tropics forest cover, this is the forest loss of carbon, a total 867 gigatons, I think, no, teragrams, sorry, which should be the same as gigatons. So there is a net loss from forest carbon gain, so and there is net loss from vegetation as well. So you can see that the perturbation of the above ground and tree cover are both contributing to a net loss. So the sum of these numbers here is 861.7, and the emissions are coming from these rich rainforests like the Amazonia, Central Africa, Indonesia, and the maritime continent, and so on. So this is showing 68.9% of the losses are from degradation and disturbance. Okay, so we can make plans for afforestation as a additional carbon sink in forests, and considering the co-benefits of forests in terms of protection for many other species, livelihoods, cultures, health benefits, food, fiber, medicine, etc. Nobody will argue that we need to increase forest cover, but it is equally or even more important to make sure that they are protected, right? Because even if there are natural wildfires and global warming makes them more susceptible to burning, they can still be good contributors to the overall drawdown of carbon from the atmosphere. So this is not an easy solution, but the co-benefits and protection together can make a solid case for forests as additional sinks of carbon to draw down CO2 from the atmosphere. Okay, they are slower, obviously, than some of the other methods, but soil carbon sequestration in general is slow, as we saw, 2 to 5 gigatons per year over a long time. But if you think of it as a portfolio of various options, then we can keep each of these, making sure that they don't become net positive as we saw in Canada or in tropical forests. So, complicated, viable, but requires lots of actions in addition to just planting trees.